Hello guys, welcome back to my channel. So from today onwards we are starting a new venture that we are going to solve 5 previous year questions every day from physics, chemistry, biology and maths. So today is day 1 and today we are going to do 5 questions on mole concept. Okay, so without any further ado, let's start the video. And the first question says that number of atoms in the following sample of substance is largest in. There are 4 options. You can pause the video and try solving it yourself first, then you can go through the solution. Okay, now see, we know one concept, that is 1 mole means 6.023 into 10 to the power 23 particles or atoms. Okay, now here 127.0 gram of iodine. How to calculate the number of moles? It's given weight by the molecular weight, right? So here given weight is 127.0. Okay, and we know that iodine has a molecular mass of 126.9, which is almost equal to 127. Okay, so we are getting 1 here. Okay, so number of moles of iodine in this scenario is 1. Okay, now it is for iodine. Okay, now let's move on to magnesium. Okay, I'm writing n represents number of mole only. Okay, it will be 48.0 by, what is the magnesium molecular weight? It's 24. Yes, so we will get 2. So we got that number of moles for iodine in this scenario is 1. For magnesium it's 2. Let's solve for chlorine. Number of moles for chlorine 71.0. And for chlorine, the number of the molecular weight of chlorine is 35.5. Okay, again it will be 2. It's for chlorine. I'm so sorry. It's for chlorine. Okay, now let's move on to hydrogen. Hydrogen, the given weight is 4. Okay, and the molecular weight of each and every hydrogen is 1. So we got number of moles is 4. Okay, 1 2 2 4. Okay, now if the number of moles is 4, then the whole Avogadro number will also be multiplied by 4, right? Means in this case it's 4 moles, here it's 2 moles, here it's 2, and here it's 1. Okay, so if the number of moles increases, automatically the number of atoms will increase, right? Number of moles is directly proportional to number of atoms. Correct? So the hydrogen will be our right option, that is 4 gram of hydrogen. Okay, I hope it's clear. If any doubt, please comment down below. Okay, now let's move on to the next question. Okay, so the second question says the concentrated sulfuric acid that peddled commercially is 95% H2SO4 by weight. If the density of this acid is 1.834 gram per centimeter cube, the molarity of the solution is. Okay, so first of all, what is given? 95% H2SO4 by weight. By weight, that means what? 95% H2SO4 means 100 gram percentage. So 100 gram contains 95 gram H2SO4. I hope no doubt here. Okay, now density is given. Density is what? Mass by volume. Density is given as 1.834 gram per centimeter cube. Density means what? Mass by volume, right? So can I say that 1 ml, centimeter cube is given, so ml, 1 ml contain 1 ml of solution contain this much gram. Okay, so to remove the point, what I'm doing 1000 milliliter, that is 1 liter, okay, of solution contain 1 into 1000, unitary method, is equals to, the point will be removed, okay, so 1834 gram. Okay, so we got that 100 gram contains 95 gram H2SO4 and 100 ml of solution contain this much gram. Okay, okay, so the mass of the solute, if I want to find the mass of solute, okay, will it be 95 by 100 into this 1834? Okay, 95 by 100, okay, into this. So we will get, okay, let's keep it here for now. We will check after, like in when we find the molarity, the calculation will check. Okay, now what is the molecular weight of H2SO4? It is 98. Okay, now molarity is what? Number of moles by volume. Okay, it can also be written as mass of solute by 98 in this case. Okay, so mass of solute is how much? This 95 by 100 into 184 by 98 for this. Okay, so it will come around 17.8 mole. Okay, so first of all, from the density we got that how much 100 ml of the solution will have. After that, from 95% of the H2SO4 by weight was given, so we got that 100% is given, so total is 100 gram contain 95 gram of H2SO4. Once we get those, then we can calculate the mass of the solute, and once we get the mass of the solute, molarity is mass of the solute by the molecule, by its molecular weight. Okay, I hope it's clear. Okay, now let's move on to the third question of the day. The question here says that the ratio of mass of oxygen and nitrogen in a particular gaseous mixture is 1:4. Then we need to find the ratio of their molecules. Okay, so when the ratio of the masses are given as masses ratio is given as 1:4. So let's say it is oxygen, nitrogen. Okay, so let's say that let mass of O2 be W. So in that case, nitrogen will become mass of nitrogen N2. Let's write nitrogen means N2 only. It will be 4W. Okay, then only the ratio 1:4 will be coming. Okay, now molecules of O2. So molecules of O2 is equals to mass by its molecular mass into Na. Okay, in the denominator only. Okay, and molecules of N2 will be what? 4W mass by the molecular mass is 28 into Na. Okay, now we just need to do ratio of these two. Ratio. Okay, let me do it here only. Ratio will be what? W by 32 into Na by 4W by 28 into Na. Okay, so W cancels, Na cancels. This will 28 will go up, fraction reciprocal, 28 by 32. Okay, this 4 is also there. Okay, into 1 by 4, 1 7. So is it coming 7 by 32? Okay, that is the ratio will be 7:32 of the molecules. Okay, I hope it's clear. So molecules of any substance of O2 anything is mass by its molecular weight into the Avogadro number. Okay, now let's move on to the next question and fourth question. So the fourth question, it's very important because it came many times. Okay, but it's very easy, it's not that hard. Just you need to do a step-by-step solution now, not in the exam hall of course, because in exam we don't get marks for our steps. We need to make it fast and we need to make it correct. Okay, so let's understand this question thoroughly. That the density of the solution prepared by dissolving 120 gram of urea, molecular mass of urea is also mentioned 60 U, in 100 gram of water is this. This is the density, as you can understand from the unit itself. Then the molarity of the solution is. Okay, so first of all, can I calculate the total mass of the solution? How? Solution contains what? Urea and water. So mass of urea is also given, mass of water is also given. So just add them to 120 plus 1000. So you'll get 1 2 0 gram. I guess no doubt here. Okay, now density is given, right? Molecular mass is given. Okay, so can I calculate? Okay, can I calculate the number of moles of urea here? Moles is what? How to calculate the mole? Given mass by the molecular mass, or given weight by molecular weight. So it will be 120 given and molecular 60. 2. Okay, now to get the volume of the solution, how will you get? We know that density is equals to mass by volume. So can I say volume is equals to mass by density? Mass is how much? 1120. Density is how much? Given 1.15. Okay, let's keep it here only for now. Okay, now molarity. Our question is asking to find us molarity. Molarity is what? Number of moles by volume. This is the volume. Okay, and number of moles we got 2. So 2 by this whole thing 15. Okay. So it will be 2 divided by 1120. Any dimension change, milliliter, gram. Okay, into 10 to the power minus 3 by 1.15. So it will come around 2.05. Okay, 2.05 m. Oh, so sorry, 2.05 m. Okay, now let's move on to the next and the last question for today. Okay, please do join tomorrow's lecture as well. Do like, comment and share to encourage us. Okay, now let's move on to the last question of the day. So the last question says an open vessel at 300 Kelvin is heated till 2/5 of the air in it is expelled. Assuming that the volume of the vessels remain constant, the temperature to which the vessel heated is. Okay, so here we can see that temperature is changing. Okay, volume is constant. Okay, pressure is also not mentioned anything, so it will also be constant. So we know that when pressure and volume is constant, our N1 T1 is equals to N2 T2. When only when pressure and volume is constant. Okay, now here we can see N1 does not changed, it is N, but N2 has changed. How much? 2/5 of the air, means N minus 2 by 5 N. Okay, so it will give you 3, let's solve it, 5N minus 2N by 5, that is 3N by 5. Okay, so we got N1 and 2. Now T2 is mentioned 300 Kelvin. Okay, T2 is everything referring to the air. Okay, 300 Kelvin. Oh, so sorry, T1 is 300 Kelvin. We got took this one. Okay, we need to find what? T2, the temperature at which the vessel is heated. T2 we need to find. Okay, now let's put everything. N into 300 in this equation we are putting. Okay, is equals to 3N into by 5 into T2. Okay, so our T2 will come, let's take this one. If this goes to this side, it will be multiplication, because in the right side of the equals to its division, 5 by 3N. N cancel, so 500 Kelvin will be our answer. Okay, hope it's clear. Thank you so much for watching the video till here. If you have any doubt, just comment down in the below and we will solve it. Okay, be it like in the comment section only we will try to solve it, or else we will bring a short video on it. Okay, thank you so much.